Hello everyone. Today let us see LED interface into the 8051 microcontroller. So as approach first let we go from the hardware to programming. That means here we are using two tools. One is Key and second one Proteus. So Proteus is a designing circuit. So let's approach from designing of circuits to the then programming. So Key is used to write the coding. So if you look out the screen, this is the actual main library. Sorry, this is the user library. Right now we don't have any component. By click on this, in the main library, we can pick the required components. We are interfacing LED to the 8051 microcontroller. So we need to search with the microcontroller name as 8089C51. So search with the 8089C51. So double click so that it will be added to user library. And second component LED. So better you choose animated LED models. I'm taking yellow color. So those two components are enough. Close it. Place here. Supposed to be I'm connecting LEDs to the port number 2. So when you are connecting LEDs to the port number 2, generally LEDs can be connected in two ways: common anode method, common cathode method. So we are following common cathode method. So I'm taking 8 LEDs. These 8 LEDs are connecting to the port to 8 lines. So always better you try to connect from LSB to MSB. So because here I'm pointing port 2.0. So in this fashion we have to connect all the anodes to the microcontroller lines, IO lines. So left side we have a terminal mode. There you can find ground, power, some other terminals are there. So this is the common cathode method. So in the common cathode method, all the cathodes are commonly connected to the ground terminal. So now to turn on the LED, all anodes are looking for the VCC. Now we are programming anodes. Okay. So to switch on LED, actually cathodes has to be connected to the ground terminal, anodes has to be connected to the VCC. This is the only one possibility to switch on LEDs. Now in our designing of a circuit, all the cathodes are stick to the ground terminal and anodes are programmable. So by programming, whenever you are writing logic 1 to the port 2.0, 2.1, 2.2, then the respective LEDs comes to on. But when you write logic 0, LEDs comes to off. The state of LED is the off. Right? That is our analysis. After that, coming to the key. So let's create the project. New microbuzzing project. And we can give the name of the, we can choose the path actually. So on the documents, I'm creating one new folder 8051. In that again I'm creating one more folder LED. Just I'm giving the name as LED. So project title Blink. LED Blink. Just we are giving the project name. save it. After that, we should choose the legacy device, search with the microcontroller name 8089C51. So here you can see the specs of 8051 microcontroller. So before working on 8051, you should study about the architecture of 8051, instruction set of 8051, and the registers of 8051. So click on no. Why? Because we are going through the assembly language. After that, take a new file. Here you can write the code. So first let me write on the notepad so that it is visible to you. The font size is bigger here. Okay, so we take in the programming, we are connected to the LEDs to the port number 2. The programming is simply, so we are following assembly language here. Move port 2 comma. My motto is switch on 8 LEDs, after some time switch off 8 LEDs. That's it. So to switch on all LEDs, I am writing FF, and after some time I am sending all zeros to the microcontroller. So between the on time and off time, we should provide time delay so that we can see the visibility of LED blinking. So in order to do that, I am taking delay separately. A call delay. It is used to call the delay. That means I am making delay as a subprogram. So in that context, I am using R0, R1, R2 registers. So 0FF means in terms of decimal it is 255. Okay, so initially R0, R1, R2 are loaded with some numbers. R0 with the 255, R1 with the 255, R2 value 02. So in order to provide the better time delay, DZ and Z, it is one of the instruction. That means D refers decrement R0 register. If the R0 value is non-zero, then jump to, I am writing loop 1. I am giving loop 1 at the same statement. So you already we return R0 to the, we return 255 number to the R0 register. Once you decrement, R0 value becomes 254. 254 is a non-zero. So that if it is non-zero, what you are saying, jump to loop 1. I am giving the target at the same statement. So it will comes to the same instruction. It will decrement R0 one more time. Here, this is the symbol indicates comment section. Let me check out. Yeah. So semicolon indicates comment section. So initial R0 value 255. When you decrement one time, it comes 254. If it is non-zero, jump to the same statement. It will execute one more time, then R0 value becomes 253. It is also non-zero, so that jump to loop 1 means same statement. So this is the loop will repeat for until R0 value reaches to 0. Once it is reaches to 0, it will come to execution of a next statement. Here again I am writing decrement R1 register. R1 is also initially at 255. So when you decrement R1, it becomes 255 to 254. 254. It is also non-zero. If it is non-zero, jump to. So this is the complete statement. Decrement R1. If it is non-zero, jump to. Again I am writing loop 1. Again it will comes to same location. And here again, this is the loop, say instruction will repeat for the 255 times. After that, it will comes to the second statement. So why I'm taking like this means it is just like a within for loop you have one more for loop in order to provide enough time delay. I'm writing like this. So as a sub program, last statement is the return. So now it will return to main program. So our program is transferred from main program a call delay to subprogram. After completion of subprogram, it will come to main program and execute the remaining part of the program. After that, after switch off the LED, again provide some time delay. So this is the action I have to repeat for the infinite times. In order to do that, I am taking the short jump to the main program. Okay, this is the actual program. So I will share this file in the description itself and end of the program. Let's copy this. This is the program. After writing the code, say your file, it will go to your folder. So I'm giving led1.asm. So it's an extension with the .asm. So after saving the code, we should add our text file to the source group 1. You can change ASM, or else you can search with the led1.asm. Click on add, close, extract this. Yes, our file is added to the target. So which are the icons for compile the code? First one, translate. At the bottom end, we have an output window. There you can see the error status. So 0 errors are there. 0 errors, no errors. So click on translate, build and rebuild. After that, we should generate the X file. In order to do that, we have an icon like a cracker symbol. Click on this option for target. Go to output. Enable the check mark. Give the check mark for the create X file and give the X file name. Suppose I'm giving LED blinking. Okay, that's my X file name. After that, you can click on translate, build and rebuild. Now definitely our X file was generated. We can see the status here, creating X file. So this is the path actually. And now come to designing circuit. This is the designing circuit. Double click. Here we should upload our hex file. So here it is. My computers, documents, 8051. So here you can see that LED blinking .hex file. So in the target folder you have a hex file. Upload. At the bottom end we have a LED icons. This is the run button. Yeah, now you can see the status. With some time delay, each LED goes to on, off, on, off, on, off. So for the best practice, everyone should start with the LED blinking. Later we can assign different conditions. Right? Supposed to be I would like to switch on only lower 4 LEDs. Okay, let's take the reverse condition. First 4 LEDs are on. At that time, higher enable LEDs goes to off, and later higher LEDs comes to on, and lower enable LEDs comes to off. Yeah, so you can see the same status over here. So you also do the same practice. Thank you.